Hey, I'm Martin here and welcome to episode 14 of my advanced modding tutorial series. Today we are going to discuss multiblocks. Woohoo! Now this episode is going to be a little bit different from what we are used to. Usually we're going to code live, however I've decided not to this time. And the reason is that it will take too long in my opinion to code it live. And also, as we've discussed entities and everything related to that, inventory for example, you should be able to come up with your own multi-block system. Though I can understand, you can't come up with it right away. So that's why I'm going to give you a hand with that. But this tutorial is focused on showing you the concepts of multi-blocks more than the details of them. After I've explained the concepts though, I'm going to show you the code I've written and I'm going through it line by line. But we're not going to write it and we're not going to debug it like we are used to. I'm going to give that responsibility to you. So let's get started. So, multiblocks are blocks that, exist out of more than just one block, and they can define some functionality, like a railcraft coke oven, or they can be, modular, they can be expanded, they can have different sizes, they can be rectangular or cubical or whatever. So there are a lot of different multi-blocks, and that's why I can't really give you the tutorial on how to do it. It's really up to you to fill in what you need. And I'm just going to give you one example, and my example will be modular storage. So the idea is that you've got a block, and I've coded it already, so that's why I can show you it. You've got a block which by default has one slot. We can attach a hopper. We can't open a GUI, I haven't done that. But yeah, it has one slot. So one piece of wool goes in and we can put in another piece of white wool. It can stack up to 64, but as soon as we want to place in another stack, it won't allow it. So that's just an inventory with one slot. The idea is that you can expand it, so we attach another modular storage, and now it accepts the slot, and it can't accept any more, but it will accept more red wool if we want to. And then we can also take it out with a hopper, and maybe on the other block, and there we go. All the wool we put in comes out again. And it can be expanded like this, but it can be any size, any shape you can think of, as long as they are connected and not diagonally and not like this. They need to be adjacent to each other. But now it will have 1, 2, 3, 4, 5, 6 slots. 1, 2, 3, 4, 5, 6, and did I miscount? Yeah, the whole part just dropped. And when we try to put in a 7th wool, it won't work. And we also are going to handle when you break a block of this multi-block and add on to it. So about every situation we're going to cover. So let's explain the concepts with this multi-block. So we've got, this is a top view of a world, and we just have one storage block. Now, when we are attaching a hopper, we've learned in the previous episodes that by implementing inventory, this hopper can interact with the storage. The hopper will get the entity at a certain location, at the location next to it, and then it will use inventory to put in items. Now, what are we going to do when we've got this multiblock? We've got 4 storages right here. Yeah, well, ultimately you only have one place where you're going to exchange information, like here with the previous example when we only had one block. So how are we going to handle that? And the solution is to use a so-called master-slave principle. It's used in not only multiblocks in Minecraft, but in this example we're going to use it as well. So the idea is that when you're interacting with a block with a hopper, and when it's a slave, and it knows it is a slave, it will go to the master and forward the request, basically. So basically it says when the hopper tries to insert an item, the slave says, well, let me send you to the master for that. So the hopper thinks it's actually interacting with the master, or actually it doesn't know, but you're just forwarding information exchange. And that's the basic idea. And to make that work, the slave, of course, needs to know where the master is, and it needs to know that it is not a master, and the master needs to know it's a master, and that kind. Now, those are just 4 blocks in our world, and there are multi-block systems where this exchange of information between slave and master is done every tick. And by the exchange of information, I mean the forming of the multiblock. So the saving of the slave saving the coordinates of the master. So it says like, oh, where's my master? Well, it's right there. So the best thing you can do is an event-based multiblock, and that's when you attach a block. When you attach, for example, the 4th block in this multiblock, you're going to notify the entire multiblock that a block has been added, and then changes will be made, and then all is fine and all is set. Everything is set. Now there are other implementations of multiblocks which involve doing it every tick or every so often. So basically they say every second check how the multiblock is structured. Now that does work, but imagine that a server has like 100 of those multiblocks. Those times will add up, and getting blocks and getting to entities is quite expensive in the Minecraft source. So if you can avoid it, avoid it. And that's why I recommend to do a event-based multiblock when you can. There are situations where you can't. For example, if your multiblock contains vanilla blocks, if you have a tank made out of stone, and you have one block that can that is your master, because there at least needs to be one block of your own mod, of course. But it does involve, or for example, a blood magic altar. It can contain vanilla blocks. So that one is forced to use intervals to update the multiblock, because if you're using a block of stone and you place it down somewhere, your multiblock can't smell something happened. So those are situations where you're forced to use a interval method. So let's discuss some situations which can happen when you're dealing with this kind of multiblock we've set up. There are a lot of them, and I want to, make sure you are, aware of those. So, for example, what happens when we remove this master block? Well, one of the 4 inventory blocks one of those storage blocks we're going to remove. And when the master is removed, we have a problem, because if a hopper is attached, where are we going to communicate the slots and items to? There should be one master, that's the rule basically. And the solution to this is just to assign a new master. Sounds simple, but well, I'm going to show you in the code what this means. Another thing is when we are going to add a new block. Adding a block is simple, and master stays where it is. But the master, where it first had 3 slots, 1, 2, and itself 3, and now should have 4 slots. So the new placed block should notify this master that it was added. And the last situation I want to show you is a addition of connecting of 2 multiblocks. Because now, when we add another block, storage block in between, this means there are 2 masters. So we need to make sure that one master gets dropped and only one master remains. And of course, that master is going to be notified again that 5 new storage blocks have been added. So we can take a conclusion from that, and the biggest one is with multiblocks there are a lot of unexpected situations. Multiblocks are quite complicated if you consider that there are a lot of things that can go wrong and a lot of things can happen. So before you're going to do a multiblock, you need to be aware of that, and you need to assess the situation in that respect. And there are many different ways to implement a multiblock depending on what you want to do. For example, like I said, we've got our modular storage block principle, which connects up all adjacent storage blocks, but you could also have only cubicle structures or tanks with specific sizes like 3x3, 5x5, 7x7. You can have those blood magic altar structures. There are many different ways to implement a multiblock, and there are different situations. So I can't really cover them all, but this is one I'm going to show you, and I'm thinking of next week showing you one that forces you to do a on interval checking of whether or not the multiblock is formed. But if you can choose the one that's the least heavy on the server, and that's the one that's working with event based. Yes. And indeed, for the most part, it depends on your creativity. In previous episodes, I've shown you how to do inventory and how to do entities, and from that you should be able to do, to think of a way to do multiblocks. Multiblocks aren't really anything special in the code. There are code, but they don't rely on anything new. Referring Minecraft code base, so I can't really assist you with that. So with that out of the way, let's discuss the code, and let's dive straight into the entity of the modular storage, the heart of the multiblock really. So at the top we can see it implements inventory, like we expect. Now I'm going to skip this code for now. I'm going down straight to the inventory implementation part, which is all of this. So, like I discussed in the PowerPoint, when a hopper is trying to interact with the multiblock, we need to check if we are a master, and if we are, we can do something directly with the inventory, because that's where our information is. If we are not a master, we need to forward our question to the master. So that's exactly what we're going to do with a lot of these methods here. We're going to check if we are master, which is a method that returns a boolean. If we are a master, return the inventory.length, which we used in our command line as well. Get size inventory. There we go. Gamma stacks was our item stack array in that case. So then we're going to return an inventory.length, and else we're going to get the master and do the get size inventory for that. So we're going to forward the question to our master. And the same happens here. If we are master, return this slot in this index in our this element in our item stack array, and else forward the question to the master. If we're a master, do it directly, else forward the question to the master. And that's done with a lot of these. Well, the inventory name isn't going to change if we're a master or not, so we're going to keep it that way. And the same is happening for those remaining methods. So that's the basic concepts of how to interact with an inventory and a multiblock. Questions are forwarded to a master. Now let's see how we implement, how we are going to cover those situations we covered. We're going to keep track of whether or not we are master in a boolean right here, which is saying is master, and if we call is master, it will return that boolean. And that is master is also saved in MBT, so when we restart the world, it still remembers that it isn't or it is a master. We also have got this boolean first run, which, like you might expect, keeps track of whether or not this is the first time the block is run. And we're using this here only in our update entity when the storage is put down in the world. This will be called only once, and this method is called, and this is a quite complicated method, so let's go over it still. Initialize multiblock if necessary. So what we are going to do, we're going to check if we know what our master is already, and if that isn't the case, we need to get to know what our master is. So this is quite a complicated method, so I'm going to try and do it very clearly. So let's start up Minecraft so I can assist myself. So the idea is when we place down storages next to each other, we need to know which storages are part of a certain multiblock. So we want to create a list of all storages that are part of a multiblock. So we can do that. There you go, that should do. So these 6 blocks are part of one modular storage. This one is not. So, as soon as we place down a modular storage, this initialize multiblock if necessary will be called for that block. The first tick it's run, and at that point, when it just started, this master is null, equals null. It doesn't know what its master is yet. So. And by the way, this master is a variable declared at the top here, which is keeping track of the master. So we're going to try and fill this list with all entities part of this multiblock. So these 6 entities in this case, we should try. And to do that, the basic idea is when we place down a block, we're going to add this block to a collection, and we're going to, for every side, so we're going to check on that side, on that side, on that side, on that side, on the top and on the bottom. So we're going to check here, or let's do it right. When we place down this modular storage, we're going to check on all 6 of these sides. There we go. For another modular storage. And if we find one, so let's put it in this example, let's put another one. Let's try, when you found a modular storage, do the same for that storage as well. So that way we're traversing an entire snake, really. We can do something like this. And eventually, by going through this, we can get to know the entire snake structure, or in this case, not really a snake. So that's the basic idea right here. And you can see it right here. So a stack, and a stack, even though as prerequisite you needed to know basic Java, and a stack could be considered or could not be considered basic Java. Let's cover it real quick. So a stack is a collection, just like a list. You can store objects in this. You can store elements in this object, but a stack is a little bit special. And so, say this is a stack object, and this is a element you want to store in it. In our case, it's entity, but let's just say it's a integer of 1. Well, let's store it, and that's fine, all good. Now, let's put in a second object, which is marked as 2. Now, this will be stacked on top of the first one. Now, when you're inserting, you won't notice anything different, but, well, let's just put in a third one. But after we get elements out of here, so a stack you can put elements in, and you can put elements out. You can't access them individually like lists. You can't really say, give me the second element. Or, yeah, like this. We can't get the second element because it's a stack. You can't take anything from the middle. And you can't do anything from the bottom either. So we need to stack it off. We need to get items off that stack. So when we take an item off the stack, we'll get the last item we inserted first. It's also called LIFO, last out, last in, first out. So yeah, that's the basic idea of a stack. Oh well, I just skipped one. But yeah, so the idea of a stack is that we can put items in and we can put items out. We can get items out. So with a list you can remove items, but it's a little bit inefficient. A list isn't really meant for that, and a stack is a little bit more suitable in that respect. The order of getting items out isn't really important in our case, but yeah, it isn't really a bad side effect. But our most important reason why we used a stack in this example is so we can remove elements as well, as easy as we can add elements. Now let me show you where that's being done. So the stack we're going to use to keep track of all storages we still need to visit when we're going to determine our multiblock. So let's just ignore this for a second. So first of all, we're going to add the storage we're putting down as our first block we're going to check. So let's consider, let's move this. So let's place down a multiblock, place down a new storage block, and as soon as we invoke this method, we're going to add this to the need to be traversing modular storages. And there we're going to say, while the stack is not empty, while there are still storages we need to visit, then take one storage off the stack, so from the top, and let's ignore this, and add this to the list of all storages in this multiblock, and that is our end goal. And after that, we're going to do what we described a few minutes ago, which is going for every side and checking if there is a storage block on that side. And that's being done right here. We're going to loop through all valid directions in a forward direction. And it might sound a little bit confusing, but it's a really neat trick to do this. because the idea is that forge direction is something added by forge, obviously, and it's a enum which has 7 values, but we're going to use 6. And you can see that it adds offset x, y, and z. So this offset x, y, and z is different for every of the 6 elements. And for down, it's offset y minus 1. Because if you're going down, you're going by y minus 1 down, if you look at F3. And if we're going north, we're going z minus 1. We can check that if we point to the north and go up 1, we'll see the z going down. So if we're going to loop through all offsets, we can have z plus 1, z minus 1, x plus 1, x minus 1, and z minus 1, and z plus 1. We can loop through all offsets, and if we take the coordinates of this modular storage block and add it up with the offset, we get its neighbor. And if we do that for all 6, we get all 6 neighbors. So that's exactly what's being done right here. We're going through every different direction we can go in, and we take our storage we are looking at currently, which is at the beginning the storage block we placed down. From the x value we are going to add the offset, from the y value we're going to add that offset, and from the z value we're going to add that z offset. So we get its neighbor from a certain direction. And then the quantity also could be a piston or a chest, so we need to make sure that it is a instance of our modular storage. And we also need to make sure that it isn't added already. So for example, if you're not careful and you're not doing this check, we're going to do the storage when we place it down. Let's look at its neighbor. Oh, that's its neighbor. Let's add it to the list of storages. Okay, and now let's do it for this one. Oh, well, this is my neighbor. Let's add it to the list. And do the same, and the same, and the same, and the same. Eventually we'll get a memory overflow. Not a stack overflow in this case. But yeah, so we need to be careful for that. So we only add storages which weren't in the list already. So these we are going to add to the storages we still needed to traverse. And so next time when this for loop is done and we get back to our while loop, this isn't empty anymore because it was filled with another one. And maybe I can show you this the best way using a breakpoint, because breakpoints are really neat, aren't they? If we're going to, this is a nice trick in IDE and also in Eclipse. If we're going to do this, we are going to right click and toggle breakpoint, and then we're going to in our Minecraft instance and right click. You'll see we just paused. And we also need to make sure that we're doing this on the server, because the server decides, so what the client is doing isn't really important, in my opinion. I think it's really interesting to see what the server is doing. So, there we go. Okay, so what a breakpoint does is it passes the code right where you want to. So we set to the code stop right here, and it does. So now the code is paused and the client is, stalled because we paused it. So we stopped it right when we were traversing our storages, and you can see this is the stack. And if we look at the elements, we can see there's one element in there, and that's a Talenti modular storage. These are all the variables which are inside this scope. And we can see the X value, Y value, and Z value. And because the client is passed, I can't really Can I unpause it? It hits the breakpoint right away. Let's try it. Okay. So let's try it again. XYZ minus 997 minus 18. And if you look at the value that's between brackets, after the X, Y, and Z value, you can see it's the right coordinate. So that's the first coordinate that's being added. Now we're going to get it off the stack. So that storage block should be, you can see ID 125, and also this one is 125. So that's the same. That's the same as this, basically. Might be a little bit confusing, but yeah. Okay, so we're going to say we're going to add it to the list of all multiblocks, all blocks in the multiblock, because that's our end goal. And then we're going to loop through all force directions, and you can see the offset y of down is -1. So we're going to get the entity at that location, and the entity is null, and that's because there's nothing under here. So it should skip it. There we go. It skipped it, and now it's going to do another one. And it's probably the top. Yes. It's up. Also should be null. And then it's going to do the north side, which is the Z value. And apparently on the -Z, there you go, that's true. On the north side, there's a modular storage block, and that's true. And so it found its neighbor. And it isn't connected, it isn't added to the list yet, so we're going to add it. So that's going to be added to the traversing storages, which previously was empty because it was at the beginning, the first one we started with was popped off the stack. It was taken off the stack. So if we look at the traversing storages, you'll see it is they all are null. Element count equals 0, meaning the stack is still empty, but after we go one step further, you'll see that it just put that one on the stack. And now let's look through that, and nothing is being added to the stack. And now we're going to go back to the while loop, and it isn't empty. We found this neighbor right here. So we're going to do the same thing for this one. We're going to get it, and it does all of that. Check, check, check. And when it finds, it will not find anything on the north side, but it will find a block on the south side, which is this one. However, that one is added to the list already, so that should be skipped. There we go. I hope you can follow along with this. It can find a new modular storage block on the east side, and that's this one. So you can see it's snaking around now right now. It began here, and now it will go on, and eventually we'll have covered all blocks. And let's press resume, and it will continue what it was doing. So at the end of this ride, we'll have a list which contains all entity modular storages which are part of this multiblock. Then we're printing it out in the server chat, just to in a log, just for debugging purposes. We should remove that afterwards. But you'll see we've got a master block at this location, and it contains 4 blocks. 1, 2, 3, 4. There we go. So remove it, you will see it will say 3 blocks, and when we add it again, 4 blocks. So after we've got a list of all modular storages, we need to notify all blocks what their master is, and if they are a master or not. So for all connected storages, we're going to say set the master to the master block, and this master block, at the beginning of this method, we're going to default it to, well, the block that's being placed down. So when we place down in modular storage, this will become a master, and it should be because it's the only block right there. And the second block you place down, this will default as a master. However, when it tries to loop through all connected blocks, it will see that one of the neighbors was considered a master already. So then we adjust that and we say, okay, well, this is the master then. Fine. Because that was a master already. So, and we keep track of this master, so at the end we can say to all connected storages that this master is your master. So when we, for example, well, when we place down another one, we need to make sure that all 4 blocks know that this is the master. So when we go to this method, you can see this will fill in the master entity, well, this field. So when we insert something with a hopper, this master is being referenced, because if we're going to do get master, we're going to return this master. So it's forwarding this master. In this case, will be this one. So if we try to insert something in the hopper, we're going to try and do a set inventory slot contents, and it's doing is master. No, it is not a master. So let's get the master and set inventory slot contents. So it's getting the master. We're doing that same is an initialize if necessary check. So this field will be filled, and then we're going to return the master, and this master will be this block. So we're going to return this block and then do set inventory slot contents on that block. It's a little bit confusing, but it's the concepts what it's about, really. And I realize this can be a little bit confusing, but I still hope I'm clear enough. And this is master. If it can determine if it's a master or not. We can simply say if the master that's, well, we're being told that this is the master. If we are the master, if the master equals this itself, then is master is true, then we are the master. If this method says, hey, this is the master, and you're basically being told that you are the master, then okay, well, I'm the master. Is master equals true. And now there are things that have to do with the situations that I explained in the PowerPoint. And for example, what happens if some block was a master but it isn't anymore? Or when it became a master, or it still is a master, but the size changed. So for example, when we place down this block, this will become the master. When we place down 2 more blocks, those 2 will be slaves. Now let's put in these 2 blocks, these 3 blocks really, and a 4th won't work. That's fine. And what if we remove this block? This block, when removed, will also call this initialize multiblock if necessary, and it does that right here. So it goes over this, and then it will notify the neighbors that it has been removed. Now when it does, it has 1 slot less, because it used to have 3 slots, now it has 1 slot less. So the master needs to be notified of that. It needs to know that when the new multiblock size is decreased, it needs to, well, get rid of 1 slot, and it needs to give back the items that were in there. So that's exactly what's happening. That's what's happening right here. If it is a master right now, it's going to check. It's going to create a new inventory. Really, it's going to reshape that inventory to the new one. Because this inventory is dynamically sized. It is 2 slots big right now, and when we increase it by 1, this array will get one slot more. So we're going to do that. We're going to say, and I've made it dynamic. You could change this to 2, and then for every added storage, you get 1 additional slot, or 2 additional slots. But I've made it 1 in this case. So 1 times the amount of storages equals 3 in this case, meaning a array size of 3. And then we're going to loop through the old inventory, and we're going to say if the new inventory is smaller than that older inventory, or that new inventory, the slot of that, the old inventory, the slot of that, if that still is within the bounds of the new inventory, then let's just copy it over. So let's put it down right here. If we go from 2 to 3, it got like a green wool and a blue wool on there. We add another slot, it will fit fine. So we just add another additional slot. The other way around, however, when we do this, oh, there still was something in there, I presume. And we remove a slot, the array size changed from 3 to 2. So when we loop through the inventory, this will go from 0 through 2. But the new inventory goes from 0 through 1. So when I equals 2 right here, the new inventory equals the length equals 2. So this does not equal true. So and therefore this entity item is being spawned. It's a little bit vague, but you can put a breakpoint right there to verify I'm right in this. So basically we're changing the inventory size right here, and then after we've done that in a nice way, we are making the inventory equal to the new inventory. We're handing it over, really. And when the block isn't a master right now, but it was. So for example, one of the situations we explained was something like this. Let's put in for 1, 2, 3, 4. And let's put in 1, 2, 3, 4. So now there are 4 items in both storages, and there's one master somewhere in here, and there's one master somewhere in there. When we add another modular storage, one master will disappear, and one of those masters will disappear with all those items in it. So before it disappears, it needs to make sure that it can get rid of those items. So there you go. That's exactly what happened right there. That's one way of handling it. You could do it in a neater way and trying to fill it in the new multiblock afterwards instead of just dropping it. But that's exactly what I'm doing. I'm saying if you were a master but you aren't right now, just drop the entire inventory on the ground. And really, I think this one is still apart from that. Yeah, I think it's just the invalidate we still need to discuss here. So invalidate is a method in the entity class which is being called as soon as a entity is removed, invalidated. So when we do that, it's invalidated, and when a chunk is unloaded, it's invalidated. So when this is called, we also need to make sure to notify the master like we discussed in the PowerPoint. So that's exactly what it's doing. It's checking the neighbors and it's making sure that it's doing it. So I'm doing this forward direction trick again, because when we remove it, we need to make sure that we're updating both this side and this side. Those two new, we went from 1 multiblock to 2 multiblocks. So I need to make sure to update both. And that's exactly what it's doing. And it's setting the master to null, because else if we just do initialize multiblock if necessary, this master could be not null still. So yeah, we really need to make sure to clear it right here. It's basically initialize multiblock, and the if necessary part is removed. And then again, if we still had something in our inventory, make sure to drop it on the ground. So that's all there's to it in this multiblock. You can make it any shape you want and it will work fine. But again, there are a lot of situations where it can go wrong. You need to be careful of that. I'm not even 100% sure I've covered all situations what can happen. Especially chunk loading is a tricky subject, because it's really hard to test it. Say what would happen on a chunk border. But yeah, next episode I'm thinking of showing you how to do a multiblock that uses vanilla blocks in its multiblock structure. So see you all then, thank you all for watching. I hope you understood everything I said. It's quite a tough subject, so if you did, well, congratulations. But it's, like I said, is mostly down to your creativity on how you can do multiblocks. This is just a concept to show you how to do it. So thank you all for watching, see you all next time, and bye bye!